typical problems and how they are dealing with it, so we can discuss about. And our first participant is Mr. Petris from University of Hamburg. He studied actually computer science at Hamburg, and he also studied for a while literature and linguistics. This is actually typical for the digital humanities fields, that mostly persons who are doing research there somehow come from both areas. He was a software developer, or is still, I think, for industry and science. He is at the moment research developer at the University of Hamburg, as a collaborator in a project by Christoph Meister, who's doing literary studies, and he's one of those colleagues who very early in the 90s started exploring the possibilities of digital humanities. It's about automated possibilities of annotation, and he's also in visualization of data. And he'll give us insight into a larger project called CATMA, and I'm very happy to have him here and very curious to hear about your presentation.
Hello everybody. Yeah, today I want to talk a little about CATMA, or Annotation and Analysis Environment. CATMA actually stands for Computer Assisted Text Markup and Analysis. First, I want to talk a bit about the history of the CATMA project. Up until 2008, students at our institute wanted to get trained in digital methods. Literary students were still treated with a tool called TACT, which is a great tool developed in the late 80s, early 90s at the University of Toronto. But the problem was it runs only on DOS, so the students first need to install a DOS emulator. There was no mouse support, and it was, for some of them, quite a archaic experience. So in 2008, we decided to try a modern re-implementation of TACT. And came up with our first version in 2009, which was a desktop installable product, mostly focused on single user resolution. Students could already exchange annotations via XML files, but mostly we made the tool for single user. Then in 2011, we received a Digital Humanities Award from Google, which allowed us to take the CATMA one step further and converted it or built it into a web application to support collaborative use cases where people wanted to work on a joint project.
Collaborate not in the sense that multiple users can access the same document and annotate it?
Right, not in this sense, but not, for example, as in Google Docs, where people. Yeah, this was the vision, but
okay.
We never made it that far, but still people could work on the same resources and see each other's work. So in this year, hopefully in September, we will come out with a new version, CATMA 6, which again has a lot of improvements for this collaborative work. Everything is Git version now, especially for larger projects. Should be quite some advantages, and also in the analysis part, when analyzing these visualizations, we have some improvements. So besides the Digital Humanities Award from Google, there wasn't a real CATMA project that funded and drove the software CATMA over all these years. We somehow managed to get it going or develop it along the way, squeezing it in other projects with a more focused research question. Currently, it is fostered by the Vortex project, which aims to disseminate digital methods more traditionally working in scholars. So, how does CATMA actually look like? What's the CATMA project? This is the top-down view. There are 4 building blocks, major building blocks: documents, collections, text sets, and team. Team is pretty obvious, members of the project. Documents is probably also pretty obvious. The documents that are going to be annotated and or analyzed. This can be one document or many documents, small or even larger ones. If you have thousands of books, we might need more server resources, but in principle, it should work. I have a colleague from the Hebrew studies who has a project with 1,000 documents in Hebrew, but all are very small, about 4, 5 to 5 lines, which works pretty well. Now I want to concentrate on the other 2 categories, text sets and collections.
Wait, the document is a text document, or can I annotate images?
No, it
must be text.
It must be text, right? We would like to have something like the PDF engine of the Firefox, for example. But still, for the analysis part, we would always need some text. But this is a feature request from the literary studies that they could see the facsimile while annotating. Okay, text sets. Text sets, as the name suggests, are sets of tags. What's a tag? A tag is the type of the annotation, so it has a similar relationship like the class or type to an instance in a programming language. Every annotation is typed by a tag. The tag has a name, a color, and can form hierarchies, which is a tool for modeling the text sets. Each tag can have a set of user-defined properties. Property is just a name with a list of predefined values attached, which are offered to the user when applying a tag to a sequence of text to create an annotation. These predefined values are offered as a selection possibility for that specific instance in the annotation. Text sets are reusable across projects, not depend on a single text, but the idea is that they evolve during a project, but also from project to project. And now with the Git version, annotations and tags can also backport a tag set that has evolved in a newer project to an older project that might be developed further.
How are you represented as RDF? How do you represent it? No, because you say it's a taxonomy at the end, it's a taxonomy.
Right.
And if I exchange it,
it's
RDF format?
No, it's JSON.
Huh?
Custom JSON format.
Okay,
Yeah.
custom JSON, okay.
And I'll come to that.
Okay.
So as you said, the text set is taxonomy. And right here we can see an example, a piece of a taxonomy or text set we developed during our last project, where we developed a text set or a taxonomy for the narratological concept of time. Narratology is a sub-discipline of literary studies, which is concerned about narrations, analyzing narrations. And the time concept in narratology explores, among others, the relationship between narrated time and the narration time. So, for example, how many times is a specific event being narrated versus how many times does it actually have taken place, that kind of thing. And yeah, then we annotated the 21 short stories with this text set and tried machine learning to train machine learning algorithm on the manual coded data and get the machine learning algorithm as an automated routine back into the platform, at least the parts that worked sufficient well. So this is an example of the need to develop custom text sets. This is one of the key features that the users in CATMA can define their own taxonomy. Because most of the concepts do not have a taxonomy which the majority has agreed upon. So, even if there were, I think it's not even a goal to reach to have a taxonomy where everyone agrees upon. In literary science, at least, it's more the goal to play around and push the borders of a definition and maybe take another aspect into account. And so the need for the scholar to play around with the text set while working with the text is crucial. This makes CATMA by design a multi-purpose annotation and analysis tool. So we do not have projects just from the literary studies, but also from the social sciences, from politics, linguistics as well. So next, I'm going to show you the annotate module, just to give you an impression of how this looks like to the user. So here's the text, which is currently at work, and the user just selects one or more sequences of text and applies a tag on the mouse menu to create an annotation, which is then displayed as a colored bar. On the right side, you see, well, you probably don't see, but I'll explain. You see the collection currently being edited in the first place, and then an excerpt of the text module. So the text module is more, if you just concentrate on the taxonomy without any text in mind. This part of the annotate module gives you the possibility to develop your text set as you annotate your text. So you can always change tags, invent new tags, change the properties while you're working on your text. And then we have the lower section where you have a list of annotations you previously selected by click, and then you can get more detailed information to each specific instance, each specific annotation, and you can edit properties or delete the annotation. So just one thing, here's a little button which says Analyze. So this button brings you right from the Annotate module to the Analyze module, which I'm going to show you now. One of the main features of the Analyze module is a query language. As I already said, CATMA does not know about the semantics of the tags, which is which follows from the flexibility the user has by freely defining them, by being able to freely define them. The downside is that CATMA does not know much about the semantics, and the query language is one method to get help from the user to put the semantics back in by being able to to construct the queries himself or herself with this language. So there are easy queries like just looking for a single word like this one, Mephistopheles in Goethe's Faust, for example. The wildcard queries, everything with a capital letter M and then 0 or more characters. You can also a query for occurrences of annotations tagged by tag analepsy, which is the narratology way of saying flashback. When you have a embedded narration or story within a story, which jumps back in time. And now we can also take advantage of the hierarchy in the taxonomy. The analepsy, the flashback, is also a flash forward, which are both sub-concepts or subtags of the anachrony concept. And if I wanted to query for all the occurrences that are either flash forward or a flashback, I could just query for the top concept.
So the text is stored as files, and then you use text retrieval methodologies to query on the text. And then when are the tags stored? In a separate database, or where do you store the tags?
Well, both is stored as files right now, and then the new version. It's JSON or text files in the case of text. And when we open the project, or the project is opened by the user, we load everything into a graph database. Tinker graph.
Text and the tags.
Right.
Okay.
Yeah, because.
When using Elasticsearch, for example, for the text fields? Because it was fun to develop the system yourself.
No, well, I tried Elasticsearch a few years ago, and
Did you like it?
it was difficult.
You had your reasons.
I had my reasons, because the
interesting. Yeah, okay.
the query engine right now combines
your query engine, or what?
Right.
Yeah.
Can work on different queries. We have regular expression queries, which go directly to the text files. We have queries that are working with an index, a pre-indexed version of the text. Then we have queries that go to the annotation, to the index annotations, which do not respect word boundaries, for example. Because we can go below the word level with an annotation, just for morphemes, for the linguists among you. Or we can also have chapters, or even things that just cross every text boundary, text structural boundary. And I think the advantage of the custom-made query engine is that we can get all of these different types of queries under one interface. Yeah, that's the main advantage, and it was very difficult for me at least to get that done with Elasticsearch.
Well, my idea had been to use Elasticsearch for the text only,
Exactly.
and then the tags store them differently, and then you have a unification right on top of it. Map it to Elasticsearch or to an RDBMS.
Federation.
Yes, and then do data integration.
Yeah. Yeah. If I just look at the
It's a new project.
if I just look at the query language and how you can combine the subqueries to look for locations, for example, it was easier to do it in a graph database and even more performant than with Elasticsearch. But I admit that this has been a lot of years ago where Elasticsearch was in its infancy, so
you don't need to apologize. We all don't understand.
okay. Yeah. The queries can get pretty complex, and for the easier cases, we made a query wizard where users can construct queries just by pointing to it. Usually, if the users start with a wizard and construct their queries, we always give them the constructed query in its syntax form. After a while, they start to build their own queries directly with the function. That's somehow the goal, to drag the non-experienced user slowly into the usage of these digital methods, even the more complicated usage. The results from the query gets first grouped by phrase or by tag.
What are the results?
The results are occurrences of either matches for a wildcard query or occurrences that had been annotated.
And not the documents themselves.
No, that's also a difference. It's easy to get documents, but I want to precise place where it occurs. At least I remember when I did this with Lucene many years ago. It was very, I needed to do a lot of wrenching, twinkling with Lucene to get the actual places where the match occurs. It works, but it's not fast. So, and the results are grouped either by phrase, or in the case of tag queries, they can also be grouped by tag. So if I have a query like the anachronic query and I have 30 analepses and 20 prolepses, then I get 50 result rows, and they get grouped by analepsy and prolepsy tags. Or this is a choice. I can look also at the phrases if they show some interesting
And I
counts.
can use Boolean logic here. White equals n% or tag equals analepsy. So what is the syntax? I can have Boolean.
We have a Boolean logic, right, and also something like a where clause. We do not have aggregation functions yet, but this would be also a nice thing to have. So we can only aggregate by the predefined things we. It's always a trade-off of not getting too complicated, because
I want to build a query engine. That's it.
So this a screenshot from the current interface, because the analyze module is not ready in Kepler 6 yet, but the principle stays the same. So we have the results here, grouped by phrase. In this case, this is Mephistopheles, occurred 287 times, and then we have Faust, the Goethe, occurred 265 times, and we can select one or more from the grouped results and show them in a keyword context like table. And I can now jump back. If I double click to on one of the rows, I can jump back to the annotate module, right to the place where the occurrence sits. Or I can.
Can I go from the right-hand table and enter there document?
Yes.
Sure. So if I double click there, I can go to the document and then read the phrase in the original text.
Right. Jump right back to the annotate module, which I showed you.
The annotate module.
Yeah. Earlier, and then you
can read it.
Right. Yeah. And you can see if this is an annotated phrase, you can see how are the other annotations at that place, or get more context. Or you can even adjust this context and make it larger. But so yeah, a double click brings it to the annotate module, and there's also a button down there which lets you annotate selections from this table. So you have something we call semi-automated annotations. So if you wanted to annotate all occurrences of Mephistopheles, you wouldn't need to do that by hand. Just query for the occurrences of Mephistopheles, select them all, and create 287 annotations in one go. Right, from here I can build several visualizations on the query results, which I'm going to tell you, in the current version, the visualization possibilities are very limited, but we have, for example, this distribution chart, which is pretty powerful despite of its simplicity. So you see the occurrences clustered into 10% chunks over the text, and you get an overview of how a phrase, in this case Faust and Mephistopheles, lay out over the flow of the text. You can compare the curves. I know these are discrete values, and it's sacrilege to combine them with a line. But if you have a lot of phrases you want to compare by curve, then it gets very gives very bad visual effects if you have just the points or use bars. Right, and this is also interactive and connected with the other modules. If I click on a dot, I get a keyword and context list with all the occurrences that form the value for this dot, and I can double click on the entry and jump back to the annotated module and see the annotated text or the occurrence of that specific instance. In CATMA 6, on the next version, we have something new.
Would that be a surprise for the researcher, that graph? Because if you know Faust, at the end, Mephistopheles is not there, Faust and Crete not there, and so on. So I'm not surprised that at the end, Faust is more referenced than Mephistopheles. So what would I, as a researcher, get out of this diagram?
This is just an example to show the visualization. But sometimes you see interesting correlations. I mean, this is nothing you can take and
publish.
Yeah, you always. It's more like a more like a heuristic function where you can have indicators to where to look to, or where to look to. Yeah. So and this might not be astonishing, but sometimes. There are effects that you cannot explain just like you did, and then it may be worth a look, closer look back to the text. And that's why we, one reason why we have this click to jump back to the text to examine the occurrences closely. Right, and with visualizations, we have the same problem as with the queries, the hidden semantics. There are only, I think, or I believe, there are only a few visualizations which work well, maybe 5, maybe 10, but there are only a few that work well in this abstract view on tags and annotations. I guess the real power could be unleashed if the semantics from the tags and annotations could be fed into the visualization, or could be used during the construction of the visualization. So what we needed is something like the query language for visualizations. And unfortunately,